And that's the reason why AI has become, a long time back people used to think that AI is a separate discipline, and people would like to do research or something would go for AI, but it has not been the case now. It has become part of mainstream. Most of the conventional systems are augmented with AI components. So, and will be actually one of the part of the course is about how you develop such a system. In conventional computing, there are subjects like software engineering and system analysis and design, and sometimes object oriented analysis and design. Now here also we'll be looking at something called expert system design process, and our expert system is something which mimics a human expert. For example, a program which acts like a doctor would diagnose, ask patient a few questions, diagnose a disease and suggest medicine, or look at your financial portfolio and suggest where to invest, and so on and so forth. So there are many programs which conventionally you cannot solve. They pose different types of and different complexity level challenges, and for that you require a different kind of solution which we call artificial intelligence. Why we call artificial intelligence probably is very clear to you now, because it's like to mimic humans with intelligence. So people, when machine exhibits similar characteristic, we call it artificial intelligence. But then AI is, and this is little actually misnomer in the sense that AI is also trying to solve some problems which we do not associate intelligence with. For example, if you pick up a chalk stick, if you're a teacher, you pick up a chalk stick, you do it every now and then, but you have never realized the complexities involved in it. Because if you exert little more pressure, the chalk stick would break in your own hands. Or if you exert little less pressure than required, then the chalk stick would fall. So such a thing, a mundane job of that type. For example, brushing your teeth is also a very difficult task. If you want a robot to do something like that, it's very hard for a robot. Or just think of a robot playing a table tennis, okay, which is a pretty hard thing. Okay, such things are not possible for robots to do even today. So seemingly simple thing on table tennis, you don't, if you just ask somebody, do you require intelligence to play table tennis, most of us would not agree that no, we don't need. Okay, we believe that is something which can be played by anybody. You don't require intelligence for it. But then computers cannot do it because it requires something else. What else we'll look at, and we'll look at solutions and of those problems, and solving these problems require different methodologies, different techniques, different ways to store knowledge. Because unless you have knowledge, you cannot infer from it and you cannot do anything. Please understand, for anything to do, you require to store some information. In conventional systems, we have databases where the information is stored, and we get the exact answer searching through the database and getting the right information, so on and so forth. For example, if I'm running an insurance company and a customer's complaint has come to me, I would like to get customers' data. I'll just explore the database and get that information from the customer, the customer database, and then I'll proceed further. Similarly here, when a doctor is diagnosing a disease and he would like to know about patient's history, and he'd like to provide symptoms and try to get a list of diseases related to those symptoms, again he'll have to search and do it. But then this search is quite different than how we do it in databases. So it is a very different domain, okay, and that's the reason why it is very important. We'll be looking at game playing, how you solve this problems like game playing, how knowledge is represented, how knowledge is inferred, and what are the lacunas. And there are multiple approaches, like what are the lacunas of one approach and why you need to go for the other approach, and all that is to be done. So all that we'll be looking at in this particular course. Not only that, we'll be looking at something called machine learning. At the end of the course, we'll be looking at this very important emerging discipline, which probably is going to overtake many other disciplines and soon in very short period of time. You probably have heard about Angela Jolie's case, and she learned that she has a probability of having breast cancer with about 87% possibility, and she went for a surgery. Now that kind of preventive surgery requires that exact calculation and all that for based on human genomes, and you may not believe, but it's huge job. And but that genome mapping, when that was done for the first time, there were more than 13 countries involved. It took around 6-7 years or more, maybe, I don't exactly remember, but a huge project it was, when billions of dollars were invested in. Now people are able to do that thing in a very few days. In fact, one company in Pune could claim that could do it in only 3 days. Now, how are they be able to do it? Because of they are deploying machine learning algorithms which could solve this problem that pretty fast. There is one more discipline which has emerged called big data, and there is something else which is associated with it called analytics. Now, analytics is about looking at the huge amount of data that is pouring in and find out patterns from it and infer something from it. For example, looking at Facebook posts or Twitter tweets, you learn how good or bad your product is, how people feel about your product, how people feel about a particular party, whether this party is going to win the next election or not. You can judge looking at those information, but the amount of information there is pretty huge. Not only it is pretty huge, it is quite mobile also. It's coming, a lot of types of information is coming daily. So the huge influx of the information, and it also comes in different varieties. Now, dealing with all this information, finding out patterns also requires different kind of approach, and AI will teach you all that. Okay, so that's the reason why I believe that one should take this course. And if you have taken this course, I must congratulate you. And what will you learn out after this attending this course? Many things. In fact, you will learn about how to represent a problem statement in something called a state space, which can enable you to solve that problem otherwise not possible. You will learn about neural networks, you will learn about genetic algorithms, you will learn about solving problems using methods, searching methods, heuristic. You will learn about how to represent knowledge. You'll learn about expert systems, you'll learn about machine learning. So the whole thing is there for you. Okay friends, we have total 15 weeks for this course. Out of that, we'll have total 1 to 7 weeks for the first phase, and then we'll have an exam and discussion forum and all that on the 8th week. Then we'll continue again till the 14th week, and the 15th week again we'll have an exam. Every week there will be a test. After every module you will undergo an MCQ will test how well have you grasped that particular part of the course. So that's what our plan is, and in the discussion forum you can share your issues with me, and I'll be more than happy to respond back to those issues. And all in all, is going to be enjoying experience for all of us. With that note, conclude. Thank you.